Big thank you to PCBWay for sponsoring this video with a very, very interesting part that we will get to very shortly because, spoilers. Hello everybody, I am Ben from Team Panic. So, I am still injured, my wrist is still all casted up, and I have a beetleweight fight coming up, which means that rebuilding the chassis and entire electronic system of the Melty Brain probably not going to happen right now. I can just about use a screwdriver, but a lot of other things are going to be very annoying and hard to do at the moment. And yeah, that does kind of mean that trying to get the Melty Brain up and running is going to be difficult. And looking through all of the stuff that I have in my workshop, I found these. Now, these are a 20-12 motor on the back of a 16-1 planetary gearbox with a nice big 6mm shaft on them that I had set up to put into a featherweight at some point. And in fact, I have 4 of them. And when I first looked at these, I dismissed the idea immediately because I just assumed that these were going to be way, way, way too heavy to put into a beetleweight. They are, as mentioned, designed to drive a feather around. However, I threw 2 of these on the scale and found it was only 300 grams, which means that the total 4 of them here are a total of 600 grams. Now, yes, that is half of the weight of a beetleweight, but I think it's possible. By making a 4-wheel drive out of these, I think that we should be able to do this. And to try and keep the weight down, I have gone to PCBWay to get a nylon print from them. And we need to talk about the chassis now. The chassis came with a ton of exploration behind it. So I first started printing small scale stuff that literally just let me see that I was able to slide these in and then bolt them in correctly, and that all of this would work as I expected it to. And with one of those, I was then able to scale up and print the big boy, and again, make sure that everything fit in and start looking at various different things. So were batteries going to fit in the space that I had left? How was I going to cover up the motor? Because of course this motor is going to spin at very, very high speed, somewhere around 12,000 RPM. So we don't want batteries or wires or anything getting anywhere near it. And you know, it kind of worked. It also let me mess around a little bit with some things, try rounding off the back of the design so that I could work out, you know, not getting stuck on my back, which is really, really good. But of course, this did come with its own issues, and you can see here, I have absolutely messed this up. I cannot get this gearbox in here. There is not enough gap in this space to do that. So, you know, this is a huge amount of printing down the drain because it was not really all that useful. But that did also though show me that yes, battery was going to be an issue, this was going to be an issue, and I needed to guard the motors better. So along came yet more prints. So we have a mock-up of the back and a mock-up of the front. And again, these were designed simply so that I could throw motors into them and just test that things worked. So this one was good because we actually managed to get the motor in, and this is one of the back ones, which is great. And then we've got these little swoops here that stop anything getting in, so all of the batteries and stuff sit between these 2 parts. And again, front one, really easy because it's literally just a box that this goes into. And you can see, I can do that all with one hand, which is great. That's exactly what I wanted out of this. And those sit together quite nicely. It also allowed me to kind of sit batteries and gump in the middle and kind of space things out. And then after that point, I thought that this project might be a little bit cursed because I had all sorts of issues printing up chassis pieces. And then eventually though, I did actually manage to get a chassis printed, and you can see I haven't even knocked the support materials out of this. This was literally just to double check that the battery could go in. And when that happened, I was like, cool, this is kind of the layout I want. But there's also issues with this. You can kind of see at the moment that there's no space for lids or anything, and the whole idea here is to be a quite low and compact robot. And we'll talk about that a little bit more when we get to the wheels, because there's a weird quirk of the wheels. So this is literally just a prototype chassis. There is no way really to bolt a lid onto this, and also it is made out of PLA. There is no way in hell we are ever fighting this thing because it would shatter and break into a million pieces. But that meant that it was time to go back to CAD once again and actually, finally, make the real thing. So this here is the fully CADed version of this. If you've seen any of my CAD things before, I normally CAD in 123D Design if I'm going quickly, and Fusion 360 when I want things to work and I want to send files out to places. So this is a brand new re-CAD of the system, fully done in Fusion 360, so that I could do things like having the holes in here with threads molded into them. Now, I am fairly confident this is going to work because the nylon material that I've had PCBWeight print for me before has been hugely dimensionally accurate. So actually having these holes threaded in the part should just mean I can throw a bolt straight into them with one hand and a screwdriver. Beautiful. But yeah, this is where we're up to. We are at a point where I have a design that mostly works. Now what we're going to do is we are going to go through right now. Uh-oh. Well, that's a problem. I swear I had managed to get one of these motors in that back section before, and this file has already gone off to PCBWeight. It is with them. It had to be with them now, because otherwise there was no chance of getting it for this video and for the competition. Even as it stands, I think it's supposed to arrive, like it's with a courier right now. It's supposed to arrive like the day before competition. So, yeah, this is interesting. I may have to like chamfer these with a Dremel, which is not something I was hoping to, like, needing to do or like wanting to have to do here. That's going to be a pain, but it shouldn't be too bad to do with a Dremel in here. As long as I can clamp the robot down onto like a bed or something, we should be okay. But yeah, so that's the chassis, and that is the thing that is coming from PCBWeight. Again, it is not here yet. We will talk about that when it gets here. So for the moment though, what we should actually do is get the rest of everything else done. So yes, this part, when it comes in, will be one piece of printed nylon from PCBWeight, but as you saw, there are bolt holes along the front here. These are for a front panel to get bolted down, because I do not expect printed nylon to be able to handle the amount of energy that a beetleweight can produce. So we're going to slap some HDPE, probably 10mm thick HDPE, to the front armor here. We're also going to put a HDPE top on this thing, because we're running 4mm thick nylon as the base, and so I figured that we should probably do like 3mm thick nylon as the top. So I'm trying out a couple of interesting ideas with this wheel. This wheel is a kind of, well, these three sub things are the kind of life cycle of building this particular wheel. This is the core hub. It is a TPU hub, and you can see it's got like a hex nut in the middle, or a hex shape in the middle, but also locking features and bolt holes all the way through it. And it's also got fins, but all of the fins have holes in them. See if we can get that into focus. Hopefully so that the urethane, or yeah, the urethane rubber that I'm pouring into these locks through these little holes and actually connects and grips really, really well to the wheel. That's the theory anyway. So because these are the same size as my regular 40mm wheels, I have actually given them the same hex hub, which means that theoretically I can actually run these in my ant weights as well if they're any good. But yeah, so these get put into a mold. This is just a 2-part mold that's got a hex down in the bottom of it to keep the wheels fairly centered in the middle, and then filled up with a 20 Shore A urethane rubber, which is fairly soft actually, which is going to be hopefully quite good. It feels quite soft, it feels quite rubbery and springy. I am actually really happy with how these seem to have turned out. Trying out the 20 Shore polyurethane is kind of the big thing here for these particular wheels, because yeah, I haven't actually used polyurethane rubber before. It seems quite grippy, it seems quite soft, it seems quite bouncy. I am looking forward to trying it basically. And the other thing here is these hubs. So as mentioned, these hubs are the same hex shape that I normally use in an Antweight. That means there's not really a lot of material around the D shaft. And to kind of compensate for that, I've left a couple of holes here which I'm going to tap and put grub screws in. So if we build this out, we've got the robot. It's here. Oh my god, it made it on time for this video and for this competition. There is so many things I should be doing for this robot right now, like molding new wheels and things, the bigger ones that I was mentioning earlier. But I gotta get this out of here and have a look at it. Also, I got some nice little like flashing ornaments, I would assume, from PCBWay. Thank you, PCBWay, that's really cool. Oh, I need a knife, hang on. All right, perfect, let's get into this bad boy. I don't really know exactly where the top is on this, so I'm just kind of gonna break it a little bit. I mean, it is only bubble wrap. That should be fine. Oh, I see a bit of it. I'm so excited. This is like an amazing Christmas present. Come on, all right, let's get rid of that. So I think that's the entrance point there. So if I can like cut that really badly with my left hand. Nope, not cut into the print inside. Oh yes. I have no idea if this is even picking up on camera, but this thing is beautiful. Oh, wow. Oh, it's got a strong, like, nylon-y smell to it, I guess. I'm not sure if this is even picking up on camera, but the detail in this thing is awesome. All right, first of all, let's try. Oh, yes, everything clicks in. Oh, that's so good. All right. Next thing to try is going to be the bolt holes. Where's an M8 bolt? These are M8 bolts that I'm running for this robot. Oh, yes! Like, that's straight off the printer, and it's just, like, I'm literally just screwing that in by hand. That's so good. I'm getting a little bit of resistance now, which is great. It's a little bit tighter at the back. Perfection. Oh, yes. Oh, that's brilliant. That's amazing. The accuracy of these nylon prints is incredible. The fact that you can literally just like thread a bolt straight into that is so good. Now, the other thing I do need to check is, did I mess up the back on this one like I did on the other one? Yes, okay. So we are going to have to shave a little bit off. Okay, so now things are coming along a little bit further. I want to get all of these into the chassis, get the electronics working, basically just do a quick systems test, because one of these motors, I put these together a little while ago, and one of these motors does not have a kV rating number on it. So I kind of want to make sure that this is the right kV before we go too much further. I have also gone in and ground down the slots at the back so that we can actually fit the motor in. Again, that was definitely my mess up in CAD. That slot actually exists in CAD, or that ridge exists in CAD, and it really shouldn't. So that is definitely on me, and again, it exists in the orange chassis, not this one, the other one. Anyway, My bad there, basically. So we're just going to get these in, which they actually do all now go in to where they're supposed to be. And then we're going to throw some screws in. Okay, we are all set up. All the wiring is kind of together. It's a bit of a mess right now because it's all kind of like out and down the sides here. But that is just so that we can test that everything works and we're all spinning in the right direction and that things kind of move. We have Annie's old receiver set up at the back here. So this should be a case of plugging this bit into this bit to power up. Cool, so we have power, all our ESCs are working, they've all been programmed to be exactly the same right now, so hopefully this works. Okay, well, that could have gone better. So they're all moving, that's a good start. However, it looks like this guy at the back here is going backwards. Front one is going forwards. Let's go front left, that is going forwards. Okay, so my two back ones are going backwards. That's could have been better, that's fine. So now let's look and see if I've got left and right the right way around. I have not. Left and right are also backwards. Yay! Okay. So that means I just need to swap my channels over to get all of that working, and then I need to swap these some of the wires on these back two motors to get these working, and then after that we'll actually be ready to bolt this thing together, which I'm so excited for. I do not even want to talk about how long that took. The electronics are so packed in here that my wire link is just going to sit out the top. That is going to mean that we're not really invertible. We should be able to drive around on the back wheels, but we're going to be running on the power link, which isn't great. Definitely a recipe for getting hit or something, but yeah, currently like this, I'm not soldering very well, so I just borrowed the electronics out of the multi-brain, and they're a bit big for this, to be perfectly honest with you. Yeah, so instead we're now just going to sit here and very quickly throw the wheels on before we get to the fun, exciting bit of the evening, which will of course be running this thing round on the floor. I was very tempted to try and push a featherweight with this thing, but I think at this point in time we're not actually going to do that. We'll do that after the competition maybe. It's just that what I'm actually thinking is that these here, which are the wheel hubs for this, these are just printed ABS. These may not hold up to actually pushing around a featherweight, or at least a featherweight chassis, even though the motors should. So I just don't want to mess with that too much right now, because these things have been a real pain in the ass to print. You are looking at the only 4 successful ones that I have out of a complete set of 10, I think I've tried to print, and they just do not want to print very well at all, which is a really big pain when I need 4 of them for the robot to actually work at all. So, alright, and the other thing here, we need to make sure, get these as far onto the shaft as we can without them touching the bolts that stick out. And we actually have less room than we were supposed to here, because the company that sent me the bolts was supposed to send me countersunk bolts, and they did not, which is a really big pain, and means that we actually have less room than we otherwise should have. Alright, we are all done, so that means it is wheel time, and the way I'm going to do the wheels here is I'm going to throw a screwdriver, hold that. I see, it's just got a bit of play in the gearbox. That's fine, as long as that wasn't slop on the actual shaft, I'm okay with that. So again, I'm just going to throw the screwdriver in there, so that I don't push these further back down the shaft than I have them already, because they are in the right spot currently. And that is actually pretty good, but it could be just that little bit better. Let's see if I can push it on a little bit further. These might need to be hot glued or something in the future. Oh yeah, that's good though. I like that. It could be on a little bit further, but I think I'm just gonna leave it for the moment. Get all the wheels on, give it a bit of a test drive, and then tomorrow, or competition day even, I can mess around with it a little bit more. Okay, got it. So because these holes are oversized, as mentioned, all I need to do is kind of push back in on the chassis and down a little bit, and that puts the wedge right on the ground, and then I can tighten that bolt up and this bolt up, and it will hold in that position. I mean, I'm going to put the other two bolts in as well, but having two bolts in, guaranteed to have everything lined up, especially considering, again, that these, yeah, perfect. All of these holes are a little bit oversized, where there's absolutely no worry about these bolts not actually lining up and sinking in. Okay, well that was an interesting test. It seems as though the wheels that I've made are not perfectly round. I think the locking mechanism I used to keep them centered just was not good enough. And spinning them by hand, especially up by the front armor, I can see the gap change. And what that meant is during the drive testing that you just saw there, things get a bit bouncy and squirrely as the front armor here and the front wedge digs into the ground quite often. So that's good and bad. The ARC arena is not perfectly flat, so I may have to end up adjusting this front armor up a little bit so that I can use it properly. I might, yeah, do that and then maybe add acetate or something on the front, although I don't know how well that would do in the beetleweight scale. The other thing is that 3 of the 4 motors here are marked as a 1000 kV motor. This back motor is not, and I just kind of assumed, oh, it's a little bit warm after that. Yeah. Yes, anyway, I had just assumed that this motor that was unmarked was also 1000 kV. I don't think it is, given that test. It was pushing harder and faster than the others. I think this is a 2000 kV, but I really don't have time to fix that issue. I barely have time to do anything else with this. It is almost competition time. So that is where we're going to leave this video. A big thank you again to PCBWeight. This nylon print chassis is just exceptional. And my God, this thing is a brick. It is all of the weight of a Beetle in a tiny, tiny little package. So it just feels so much heavier, but it is at 1.2 kilos. So we are bang on the money for a Beetle weight. Yeah, that's going to be it for this video. I hope you've enjoyed that one. And if you want to see this thing fight, subscribe, because there will be a fight for this thing coming up. I don't know if I'll put it out over Christmas or if I will push it out in the new year, but it will come out at some point in the near future. Anyway, hope you enjoyed that one, and I will see you in the next video.